Hi everyone. In this tutorial, I'm going to show you how to use the QCORR module of AQME to carry out the post-processing of computational chemistry output files. In this case, I'm going to use outputs from Gaussian, but QCORR can also analyze any outputs from other software like Orca, Turomol, or any other program that is compatible with the CClib parser. So first, we need to go to the main app repository of AQME and then get inside the AQME workflows folder. Then we get into the QCORR processing QM outputs folder, and we are gonna download and open the QCORR standard analysis and full check Jupyter notebook. I'll open it on my computer with Visual Studio Code, and as you can see, the title indicates that QCORR is gonna analyze output files from Gaussian and fix the issues from error terminations. The files we are gonna analyze are in a folder called QCORR1, which is within the AQME folders. In this folder, there are multiple files with different termination types, but you can analyze your own output files instead of these pre-default ones. So basically, the QCORR module runs with three options. This is the working directory with the files to analyze, type of outputs, in this case asterisk.log to select all the log files in the folder, and this last option detects calculations that converge normally during the optimization process, but didn't converge afterwards in the frequency calculation. There is a link from Gaussian in the description of the video where this issue is explained in detail. Now we're gonna run the program with Ctrl plus Enter, and as you can see, QCORR starts with analysis of all the output files, and you can see how in each of the files they are analyzed pretty quickly, showing the type of termination and error types. Then all the files are moved to the successful and unsuccessful folders. In this stat file, we have all the information from the QCORR job, including the names of the files, the termination class, and the error types. Then the CSV file contains all the statistics for the job. So from 25 files in total, we've got 5 normal terminations, 3 single point calculations with normal terminations, 3 calculations with extra imaginary frequencies, 1 transition state with no imaginary frequency. There is also a calculation that didn't converge as a stationary point during the frequency job. Then a linear molecule with the wrong number of frequencies, which happens because the calculation has the wrong group symmetry. Also an SCF conversion issue, a calculation with no data, which happens, for example, when a calculation fails to start in a supercomputer. There are a couple of errors for calculations that use incompatible PC sets. Also other errors, such as unfinished calculations. One calculation with spin contamination. And finally, we have also one duplicated calculation. Now I get into the successful folder, and you can see all the normal terminations. The spcalc subfolder contains single point calculations such as energy and NMR, and the JSON file subfolder contains JSON files for the successful calculations. Let me open this one, for example, and you can see how the file has many parameters of the calculation, which you can use later on to train a machine learning model, for example. At the end of the file, there is a section about metadata that contains the program and version used, keywords, and so on, which is very useful to improve the transparency of the computational protocols that we are reporting. Now, the QCORR job also generated a file called QCORR full check analysis. This file basically verifies that all your calculations are run with the same parameters. For example, here you can see how different versions of Gaussian were used among the calculations, like Gaussian 09 in 3 cases, and 2 cases with Gaussian 16. These types of errors are quite difficult to spot manually and often go unnoticed. Then there were also different git types, like SG1, ultrafine, and fine. Also different levels of theory, like MO6 to X, B3LYP, and so on. In this case, no dispersion was used, and the solvation was different. Some of the calculations were done in gas phase, while others in solvent phase. Overall, this is a very important file to ensure that the same parameters are being used within the same product or publication. Now, let's go back to get into the unsuccessful folder in the first run. And as you can see, all the files are stored within subfolders according to their errors. Here we open the duplicates error and you can see the file. And also, we're going to get to the fixed QM input files folder, which is perhaps the most important one. Here you can see different conf files. And let's open, for example, this image conf file. Basically, QCORR creates a new input file that will try to fix the error encountered in the original output file. For example, in this case, QCORR will displace the extra imaginary frequency and will create an input with those new coordinates, trying to get the right intermediate with no imaginary frequencies. Well, and that's it for this tutorial. I hope that it was helpful for you. And if you have any questions related to QCORR, please don't hesitate to send us an email or just open an issue in the GitHub repository.